Let me start. Okay, welcome team. Session 9 of our GenAI journey. So last 4 weeks, 8 sessions we have done. I'll just give a recap before we get into the second half of our training. The first 4 weeks we have learned about LLMs, basically the GenAI landscape, the evolution, the LLM, what LLM is, what are different types of LLMs, what are the different vendors who are building LLMs, right? And then what are the use cases of GenAI or LLM in general? And we talked about the different types of models, the embedding models, the text models, the semantic search, embedding model, semantic search, and then vector databases. We talked about quite a few vector databases. We built semantic search applications. And then we talked about RAG architecture. We used LLM with that, and then we built RAG with various frameworks, LangChain. We used LangChain to build the RAG, and then we also explored no-code platforms. We did Langflow and we did Bedrock, AWS Bedrock. So that has been the journey so far. For the first 8 sessions, we have done all of the first part, the RAG architecture. We have completed components and about LLMs. So the second half, as I said, we'll get into the agentic and the LLM ops side of it, basically the guardrails, the deployment, monitoring, observability, basically, right? And the building agentic AI applications, of course, with different platforms. Again, the using no-code platform like Langflow, Crew AI platform. We look at Agno framework and using LangChain as well. Okay, so that's the journey has been, and that's what we're doing. So let's get into the today's session. Introduction to agents, about what agencies, how they work, and what we do with that. Let me share my screen. Okay. So there has been a lot of buzz around agentic AI. I know the future is all going to be the agents and agentic AI. What do you know? Anybody who can talk about what is agent and why? What do we mean by AI agents? What's the capable of? How they are being used? Anybody who has knowledge or experience or worked with what is an agent? Why we're talking about agents?
I think if you want to do the multiple task on some particular thing, instead of doing a manual intervention, the agents will talk and do the work and give the final result for us.
Okay, so you're saying multitasking can be done by the agent.
Yeah.
Okay, yeah. Anybody else?
Yeah, for example, I'm creating a pipeline daily basis, right? So insert agents will be creating the entire pipeline. It will be taking care of the monitoring all the activities. So we can replace human activity with the agents do the activities.
Yeah, that's close. But you can even do automation. So we have been doing for decades now. It's all replacing human activity or repeatable activity by doing automation, right? So automation is the first thing. Basically, whatever you have to do, first thing you looked at in IT was how can we automate that? How can we orchestrate? How can we schedule? How can we automate that part? Correct. So that's been there for decades now. Replacing the automating basically and replacing the human with the system activity. Right. All right. So agents at the very core basically are a wrapper around our LLMs, giving them additional capability. Now, if we talk about LLM, all through the first 8 sessions, 4 weeks, we have been talking about, we had 2 limitations. Can anybody tell me about what it was? Throw some light on that. What are the two major limitations that LLM has?
They don't have a current. I mean, they learn for the previous, right? So they don't have the
Correct. So
day-to-day
they don't have knowledge of the current affairs, latest information after they have been
training,
released of their cutoff training date. Okay, that's one. What is the other one?
and they don't have the, I mean, private information which we want to look for, right? Like they have the
Right.
public information.
Yeah, awesome. So, yeah, Srinivas, you've been very diligently following, I guess. Awesome. Appreciate it. Nice. Yes. So they don't have access to private information or personal information. Now, what agents do is address these limitations. Of course, the personal information is, anyways, they cannot address. I mean, we have been doing the RAG for that, right? So that's first part of it. So the RAG can be added. That's one limitation that you address. The second part is about how do you give current knowledge, right? So there is not much use of an LLM which has an historical information. It's more like a library, more like Q&A or Wikipedia, right? So you ask some questions, general knowledge, it will give some answers. Fine, great. Then what is the commercial use of it? How do I make it a business use case and build it a business use case? How do I get ROI out of it, right? If I'm not able to make it commercially viable or make it useful for my industry use cases, there's not much use to it, right? So just answering general knowledge questions, is good. It's most of it is entertainment, but it's not. Unless, as we said, we address these two things. It can answer questions from my data, first thing. Second, it has in knowledge of what's going on around currently, latest, right? So for any research related activities. So what agents do is they take the LLMs and then they give these capabilities. So one is latest. How do we get latest information is the something called tools. Okay, so we'll talk about this. We'll go through, we have done to that the RAG architecture. Now we'll talk about the agentic architecture. Agentic AI refers to systems designed to exhibit autonomy, proactive decision making, and goal directed behavior to solve complex problems. So, an agent is mainly focused on solving a problem, a complex problem, which it can do on its own by taking some proactive decisions autonomously. Without human intervention, it can take some decisions. Basically, you write a lot of if and else conditions, you write evaluations, and then you say, hey, if this happens, then do this, then check this. If this is not correct, then you do this. So all of that you write. An agent will take over all of that. It will take over and it will make its decisions autonomously. Okay. Do I have to do this or do I have to do this? Okay. Is it correct? It will reason with itself. If not, do I do something else? Okay. So those kind of decision making. So this is my goal. I have to solve this. Is this problem solved to my best of my knowledge? If not, then what else I can do? What do I have? So all of that thinking, autonomy, and decision making, it's done by the agent. That's what an agentic AI refers. So the main things are autonomy, proactivity, and adaptability. So autonomy is it operates with minimal human intervention. So it can take decisions on its own. Of course, again, guided by the rules, limitations that you give it, the tools you give it, right? And based on the problem and the resources it has. Proactivity, it initiates actions based on context and goals. Based on the goal that you give it or a problem you give to the agent to solve, it does it. It learns and evolves in dynamic environments. Yes, it's basically has some internal feedback loop mechanism that it can learn based on what it's doing, where it is currently, what has been done, and how I can improve over it. So all of that mechanism is built in with the agent. So what consists of an agent? Basically, architecture is at a very low level. LLM agent has only three parts. One is the first LLM, which is a heart, you can say, or brain, you can say. LLM is the brain of the agent. Then it has memory and it has tools. These are the three major parts: an LLM, memory, and tools. Just these three things. Planning, of course, it comes. Basically, it does one of us activity, reflection, self-critic, query routing, all of that it does as a routine process to achieve the goal that it has been given. But the main components of agent is just three things: LLM, which is the brain; memory, short term or long term; and tools. The tools is what gives an agent access to the current information. So think of agent as a handyman. Okay. So he has a task to do. It can be plumbing, it can be wiring, it can be whatever, internal home stuff that we want to do. So a handyman has multiple skills, right? So if you call a plumber, he's only specialized in plumbing, and electrician only in electrical and all. So a handyman is kind of a jack of all. So he knows bit of most of the things he can fix. So he has consider him as an agent and LLM. So, but he needs, if he has to do plumbing, he needs some tools. If he needs to do some minor electrical work, he has something. He needs to do some desk jobs, something he needs, right? He needs some backyard work, he needs something. So there are different tools based on what his goal is or what his problem is to solve. So those are the tools that the handyman needs. Similarly, the agent also needs the tools like, hey, if, for example, the same prompt that we have been, how is the weather today in Dallas? The question it takes to the LLM does not have access to the current data, right? So it can answer in general about weather, but it cannot answer about a particular city in the current date. So then what you do is you give it a tool. Okay, you don't have the access or you don't have the knowledge. So I'm giving you a tool which you can use to get that information. So that tool can be anything. It can be a calculator, web search tool. Let's say I have a web search tool, a tool with which the LLM can search the internet. If it can search the internet, it can get the current weather, right, for any city. Yes? No?
Yes.
Where does it go to do? If just as for example, if it wants to do the web search, welcome Neeraj. So if it wants to get weather information, where can it go? Let's say it has a tool that it can now do the web search.
Go to weather.com.
Exactly, right? So it can go to either Google or it can go to weather.com or any other weather apps or weather related websites that are available. It can scrape and go to that site, read the site, get information for that particular task, and then it can give you. So it's the tool basically that to get the information. But what information you need to get? How do you get? Right? So that is again different. So each, if you go to website weather.com, what do you need to ask for weather.com is all the decisions that the agent has to take. So it has to understand, oh, I have a web search tool. Where do I go and search? So it can go to Google, search. It cannot stop there. If you go to Google and search, just get results. But did I get the answer? No. So then what next I have to do? Take one of those links, click it, and then open. Or let's say go to weather.com directly. Now I am in weather.com. But is it done? My job done? No. What is my goal? My goal is to find what is the weather like today for Dallas. So in weather.com, I have to search for weather for Dallas. So it has to do a search for Dallas there and current date. Then it will throw some information. It has to bring back that information. Then it has to process that information and then give you a human readable in a nice formatted way that, the report kind of a thing. So all of these tasks are automatically handled by the agent. You are not going to guide it step by step. All you're going to do is, hey, this is the problem. This is the tools you have. You go and solve it. That's it. That is where the agents are specialized. That's why there is a lot of interest and the future is betting on the agents, everybody. So if you have seen recently, ChatGPT has also released agentic AI platform. It's called Agent Kit. It's more like anything like workflow automation, same thing, but now you can do it on the OpenAI itself, right? So in a nutshell, this is what it is, an LLM with goal and tools. Of course, it needs memory because what I talked about, all of these steps, it has to store somewhere to understand where it is and what it needs to compare. Now, it used the tool. First, I asked the question. It knows it does not have anything. It cannot answer itself. Then it knows it has to call a tool. Then it has to search what tools it has. Then take the decision as to which tool it can use. Then use that tool and call that, use the tool to get that information. So if it is a web search tool, it goes and searches the web. Once you get the information, understand if that goal is done. Now, what query do you send to the tool, right? And the tool goes and searches and gets information, then process that information and give it. So at each point of time, it has to do self-critique. Whatever do I have that information, is it correct or not? Or have I reached the solution? Or do I have to do more, to get a better answer? So all of this is done within the agent. Okay, any questions? So we talked about the RAG architecture, right? Similarly here, what we do. So this is an agentic AI architecture. As I said, at the center, we have an agent. You see, this is an LLM. This is the brain. Okay, for the agent, this is the brain. It has a task and you can give it a role. So each agent, so in general, a multi-agentic system has multiple roles. Each agent has a specific role to do. We look at when we do multi-agentic systems. Let's suppose a plumber, so a handyman, today he's playing the role of a plumber because there is a plumbing problem kind of a thing. So agent here can give it a role, and then based on the role, so what is the task that he has to accomplish, the agent has to accomplish, what is the task. We set memory, it has short-term and long-term memory that it can. Okay, so the short-term and long-term memory and planning it has. Then on the right side, you see these are the tools. So as I said, tools can be anything. It can be a calculator, a simple calculator. It can be web search. It can be Gmail and Slack, which means integration to these internal organization tools. A vector search engine. This is our RAG part, right? This is a collection. Remember, we created collections and then we can do a vector search. So this is the complete RAG. So one of the tools can be your complete RAG. One of the tools can be a calculator. One of the tools can be a web search. One of the tools can be a mail or Slack. Okay. Let's say calculate the amount to be paid based on the company policy for the leave encashment is my problem. Okay. Now, I just gave it to an agent. And then you also say, let's, based on the market price, how much shares, whatever, you have to give something like that. Now, first thing is, when I said according to the policy, first it has to get how many are the, maybe the leaves that this person has. So it might be company internal information. So I have built a RAG for that where you can go and search for the customer and then RDBMS or the policy to get how many leaves he is eligible for encashment and all of that. So you get that using that vector search tool or RAG that you give it as a tool. You get that information. Now you have to do some calculations. You can use the calculator agent. Okay, internally LLM can also handle simple math. Let's say there is a complicated problem that you want to solve. You can use the calculator, math problem. If you want to get the latest price, you can use the web search tool. Go to web and go to that stock market or finance related websites, get the stock price for today, those kind of things. Now, once you get all of this, figure out, combine all of this information. So each response that is coming from the tool is stored in a short-term memory that is within the application, or long-term is you are storing to another database. It's cached in the database where you can bring it back. And then once you combine all of this information to prepare a response, and then maybe you have to send out an email. So you connect to the Gmail tool inbox, and then you send out an email. So all of this processing is done by the agent. So it can do multiple calls and figure out until the task is completed. So that's all the architecture with a single agent. Now, if you want to do, so these are the steps, right? So incoming user, you have initially, earlier you had only LLM. Now you have it's an agent. So agent again has LLM. So LLM will define the steps to answer query given suite of available tools. So what are the tools? Tools, as we said, it can be code execution, document search, calculator, weather, chart builder, whatever. Then it executes steps. If it don't find the information, it can run a loop. It can call multiple times the tools, right, to get the proper answer. Multiple iterations it can do, call different tools or call the same tool with different query, kind of a thing. And then once it is satisfied, it has the correct information or the best answer it could give, then it would return the final answer. Okay. Still have another one second. Give me 1 second.
There's just one question.
Yeah,
Why
yeah.
we need to have calculator as a separate tool? It should be, is it a live or something? Because it's LLM itself can understand, can answer, right? The calculations.
Sorry, come again.
Why we
Which
need
one?
a calculator as a separate tool?
Calculator.
Yeah.
Yeah. So simple calculations it can do. That's what I'm saying. Let's say you want to do some algebra, right?
Mhm.
Or some complex mathematical calculations, calculating n-dimensional length or whatever, integration problems or math problems or logarithm problems that you want to solve, you can use a calculator too. It depends, right? So capabilities. It's just a tool if you want to use for extra features, extra complexity that it cannot handle. Because language models are not supposed to solve math problems. Of course, they can to some extent, they have that intelligence, but that is limited, right? They are not a math tool. They are language tools, right? Their core area is language processing, natural language processing, to understand the language and respond in a NLP, using NLP. Now, these are all, yes, it's capabilities, but they have limitations. So if it is a complex mathematical, of course, they are evolving, they are building everything into it, they're getting padding up with a lot of features. But let's say you want a specialized integration problems or calculus problems or arithmetic geometry problems that you want to solve, you can use a calculator tool. Okay, or anything. You can write your own tool in Python, and then you can also do that. So I had one of, okay, I don't think we'll talk about, I don't know where that slide is, copy. Okay, I think we are just the slide. Okay. Yeah. So if you look at this, now we talked about the agent, right? Now this is how a multi-agent system looks like. It's not RAG system, it's multi-agent application, you can say. The same thing, but now you can have multiple agents instead of single agent. Now each agent will have a specific task or role to do, and then there will be a supervisor agent or a master agent, which is giving or breaking down tasks and giving to these agents, or what are all the agents that you have. So each agent capability, let's say I build one agent only to handle the RAG, internal data. Now, internal data again can be your HR data, your order data, your finance data, whatever it is. So I have a tool that can connect to collections basically based on the question. So if you want finance data, so I know I built finance in collection B, so I create a tool which can connect to collection B and get information, RAG. Now, if I have HR data in collection A, if I need HR data, I create a tool that it can connect to collection A and get the information. So it's all like branching. So let's think of a project. Okay. So, and the retrieval agent or the master agent is a project manager, right? Now, the project manager gets query, which is the requirements, and then he has multiple teams. Let's say one is the front end team, one is the back end team, and one is DevOps team. So the front end teams is, let's say, agent A. They have their own skills and capabilities, right? The skills are like in the Node.js or Next.js or whatever, UI, UX, all of that they can build. Now so that agent for the front end, all the front end tasks, the manager will give it to the front end team. So agent A can be the team lead, basically. So that lead will take that, and then he has tools. Tools, you can say the team members, which have their own skills. Now they take that up and then do that part of the requirement, building, development. Then you have team B, which is say backend team. Now they do all the database creation. So that part is given to them. They have their resources. They will build that. Team C can be another team lead, which is DevOps. So they build CI/CD pipelines and the repos for version control and all of that. Now all of these are managed by the manager. So he will take care of assigning or managing all of these tasks to all of these leads, and then get the work completed and then give it back as a response. That's the same thing that is replicated in the multi-agent architecture. So the main supervisor agent will get the task, he will split it down, then he will know who are my other agents available, what are their capabilities, and what tools they have. So based on that task, it will call that agent to complete that particular task. So that agent will take the task, and then it will look at what tools it has, which tool it can use to execute and get the response and give it back to the supervisor. Then based on that, it might use that information and call another agent to do the next task, or it can call all the agents in parallel as well. A typical example is, let's say you want to book a vacation, right? So most common example that use. So the booking agent, so there will be a first research agent, then there will be a flight agent, then there will be a hotel agent, then there will be a local car rental car agent kind of a thing. So they have their own tasks. So first the agent will give it to the research agent, where it can research based on requirements. Let's say I have this vacation, this is my budget, this is the place, and these many days. How do I do the plan for it? So the agent will go do some research, get all of the information within this budget. These are the things, these are the things you can do. You can take these flights, these hotels, and all. Then it will go to flight agent, and then it will search all the available flights, the next step. So it will go to the flight agent. It will search for all the flights, cheaper flights, or based on the time, day, time, what are available, and give you all of that. Another can be hotel. So based on which day where you are staying on the itinerary, it can search for hotels. That's basically what a travel agent does for you. All of that stuff can be split into each agent, and given the tools, they will come back and give you. So the hotel agent may have access to, remember we did something, so it can have access to, say, Airbnb, some MCP tool or Airbnb site that can search, hotels.com website it can search. So all of this combine, and then it give you the best features. Flights can be, it can search with various online flight booking websites that it can bring. So all of this is orchestrated by the main agent to the sub-agents, and the agents use the tools to complete that particular task and give it back the response. And based on that, it will take decisions. Once everything is done, it will give you a final response with all the plan, itinerary, options to do. And maybe take it one step further. If you give access, so human in the loop, it can ask you, hey, should I go ahead and book this hotel now? If you say yes, and you give the card details, it can also go and book that for you. Same thing with the flights, but you cannot independently give your card details and hope. It might be in future, but not yet. So there is always a human in the loop that you want to say yes, and then it can go and book for you. That's the multi-agent architecture as a whole. That's how this looks. Okay. Questions? Any questions? No?
In the architecture, can you throw some light on planning? Where does it come?
So that is actually internal to the agent, how it plans and orchestrates what task has to be done first. So of course you give some sequence, but it can be parallel, right? So then the agent decides which agent it needs to call first, get the response, and take a decision as to next what agent it has to use. So all of that is the planning. How do you orchestrate the sequence of events that it needs to solve that particular task? Okay. Now, so these are all the different frameworks. So there are many more. Basically, you can build with LangChain. There is something called Agno framework that we will explore. LangChain, Agno, CrewAI is something also we will explore, how to build multi-agentic application with CrewAI. There is Langflow, we have done RAG, so same thing can be used to build agents as well. We'll explore that. If time permits, then LangGraph, AutoGen, as I said, Agent Kit from ChatGPT, N8N, Zapier, right? So all of these, make.com. So all of these has the same workflow automations using the agents. So basically building, provide the agents to build the applications. Again, you're not going to build an agent from the scratch. Building an agent is use the libraries frameworks. As I said, all you have to provide is those three components. LLMs, we know, just like in RAG, you can use any of the LLM within the agent. And in a multi-agent architecture, it can be a different LLM in each agent. That's fine too. Then again, it depends, right? So a summarizer or a summarizer agent may not need a huge task. So you can use just a mini small LLM that is very specific to be used. Whereas if you have a code generation thing, maybe you can use Claude Sonnet 4 or something, specific to that model. So you can use multiple models based on the use case within each agent. Then you also provide tools. What tools you can provide, we'll see. So you have to just call this framework, give them which LLM model that you want to use, which tools you want to use, and then memory you can do just internal for now. External is again like integration with any of these databases, vector databases or Redis cache databases, where you write and then read from there. It's standard caching kind of a thing. So just give these three things to the model, to the agent, then you're good to go. Okay.
Harun, I
So
have a
that's,
question.
yeah.
You mentioned about N8N, right? But is it in the same league as this framework? Because N8N is, I mean, the way I know, is more a workflow automation, right? It may
Yes.
not need integration with LLM. It's more rule-based. It's intelligent workflow more, in my view, isn't it? Or is it different?
No, it also has agents. N8N also has a agent-based workflow automation, but it's AI-based automation, where again, workflow automation, as you said, rule-based. You set up the rules, but here in N8N, you can use the agents and then give your LLMs, give your tools and everything. Same thing you can do in N8N as well. You build the workflow automation, but with AI built it with agents.
Okay, interesting.
Yeah, it is. All of these are AI automation, workflow automation with AI. It's more like UI based, where you can actually build the
Yeah,
automation.
I know I experimented with it a little bit. It does not
Correct.
even have we are still with the community version, right? The enterprise version is still not out, but so far I've not seen agent. Maybe I have to see that. That's fine.
Yeah, you can explore. Yes, it is available. So you can add agents. It may not call it agent, but it's the same thing. You have UI based. It can show what it is.
Okay. My other question is, like, when you talk about this multi-agent scenario, it includes this multiple agent, multiple framework as well, right? Or is it within one framework?
It is mostly one framework. You have multiple agents. You just use
Okay.
one framework, because once you trigger that supervisor, it will call all the individual agents. But the entire thing is one framework. It's not like one agent in N8N and one agent in this thing. So you just use Crew AI. You can use 4, 5, 6, 10, as many agents as you want. And just, it's like create all the individual agents and combine it in a list and give it to the supervisor. That's it. Okay, these are all the agents you have available to you. And each agent again will have a list of tools that come with them.
Got it.
Now the supervisor will give them, it will look at, hey, these all I have, this is my problem. and these are all the agents I have to solve it. So it does all of that processing, calculation, splitting the task, and assigning it to agents based on their agent capabilities and tools they have to solve that. So that all that intelligence is built in the agent.
Okay. Okay. Got it.
Yeah. And see, innate and flexible AI workflow. See here, the AI agent. It has the chat model, that is the LLM. You can use Anthropic or anything. You're able to see the screen?
Yeah. Yeah.
Okay.
Okay.
Yeah, see here, it has the LLM. It has the memory. For memory, it's using Postgres database. Tools, it can use, it can connect to Jira, it can connect to Entra ID, it can connect, you can add, see plus here, click the plus, and then you can add the tool basically. So this is your complete agent here plugged into your workflow, automation workflow. So here it is again conditional. So it's a create user. Once you get the create user, it can use all of these to do the task, what are all involved in creating the user. And based on whether that user is a manager or not, conditional here, you can do these tasks again, kind of on user onboarding. Now, do you really need this? Can I build everything rule-based? Yes, you can. Right?
Yeah. No, the thing that I have built, Harun, in this is like maybe it's a different use case, right? Is that it is primarily event driven. That's why, if you look at it says
Sure.
workflow automation, right? So it is mainly event driven. It's not autonomous agent as such, like the way you built with Clio AI or others. That was my how I saw it.
Yeah, I mean, so typically this can also be right. Create user form submission is an event. Once you say give a new user, you want to create a new user account or new employee onboarding, you fill a form and click submit. That's when this is triggered.
Yeah. No, it's okay. I got it. Things are evolving,
Yeah.
right? Everything is becoming everything now these days. So
Correct. Yeah. All right.
maybe the time when I look at it was different. Now it is a lot different now. Okay.
Yeah. I mean, yeah, everybody's getting into everything.
Yes, that's the thing, right? It's hard to say which one is what is this.
Okay. Yeah. So as I was saying, we have all of these platforms to do, build the multi-agent applications. Okay.
One more follow-on question, Arun. There's the orchestrator or the supervisor or the coordinator agent. Is that something that the per application you have to build it, or is it something that comes as a default that you could optimize and
That is also just simple another agent. It's just it has a
Okay,
different role as supervisor.
Okay.
So you just define it as a supervisor. Some frameworks give you a normal agent and a supervisor agent. It's called, if you say crew AI, it's called a crew, where you have multi-agent architecture. But you can just make any agent as a master, just like in a cluster of machines or a cluster when you build, you can make any machine as a master. Choose something as a master and other as workers. So same thing, you can give a role for the agent as a supervisor agent, and then you can give other normal agents. Okay, it's not that all of these also have supervisor agents. Some of them have, some of them don't have. So where you can orchestrate in sequence or in parallel for all the agents.
Okay, got it.
Yeah. Okay, so demo, let's get into it. Standard, so libraries I have built. So let's go step by step. And I have just OpenAI key for this. Now, what I'm doing here is I said use the LangChain, right? So in the LangChain core.tools, you have something called a tool. Okay. I'm going through basic, so you LangChain, OpenAI, LangChain community, you may not need all of this, but so you import a tool and import chat OpenAI. So using this, you can just declare a notation. You can make any function just as a tool. So this is basically you are writing a Python function to add two numbers. So this is a tool, okay? And this is the most important part for the tool. The comments within the tool. This will what help the agent to see. Remember again, it's not, there is no magic potion. The agent does not automatically know everything. When you say the agent can take a decision, it's based on the information that you provide. It's just like a prompt that you give to LLMs. As much metadata you provide, the more metadata you provide to the agent, the more intelligent decisions it can make. Okay. This function multiplies the provided two numbers and returns the result as a string. So when I give the tool, it parses all of that code, it understands the metadata, and then it remembers, okay, there is a function, there is a tool that can multiply two numbers, right? So when there is such problem that it has to solve, it knows that it can call this function or this tool basically that can do the multiplication. Of course, you can say that, hey, an LLM can do a simple multiplication. Yes, it can do. This is just for the example purpose. This this Python function can be anything. You can write an entire API, entire application just in a function and call it a tool. That's it. Okay. You can build a complete RAG and call your RAG application from here. You can write a database connection and write SQL queries, get data information from the database, summarize, and get it back. All of that can be just one tool. Okay. One function, and then declare it as a tool. So it becomes your tool to talk to your database. This is the entry point. Now, within that tool, there is no limitation as to what you can or what you cannot write, as it's an independent module kind of a thing. Okay, plug and play. The agent will call the tool, right? And then pass it information that the tool needs based on, say, parameters. Now the tool will understand and take that and do whatever based on the code that you have written in the tool and send it the response back. Now, same thing here. This function adds the provided two numbers and returns the result as a string. Now I'm creating an LLM called Chat OpenAI. Model I'm using GPT-4o mini. Okay, so we are going layer by layer. There is no agent here yet. Okay, all I'm doing is creating a tool and creating a LLM. Right now, first thing is addressing that problem. That LLM does not have access to the latest information. So what I do, LLM dot bind tools. So I am binding some tools to the LLM. Now I call this LLM with tools. What am I adding the tools? Multiply and add. So these tools I am binding with LLM and having a runnable, which is called LLM with tools. Now, let me run this. We'll see how this will work. Okay. Now, I'm just asking a question. LLM with tools dot invoke. What is the capital of India? It is New Delhi. Okay. Does it need a tool to do this?
No, I
No.
think it is
No, right?
based
So
on
it is a general knowledge. Okay. Now, AI message, this is the content, response metadata, tokens, all of this it has given, model that it has used, all of this, output token, input tokens. Now I'm going to Now I'm going to give these prompts. What is the result of 5 multiplied by 3? Now, when I do this call, okay, see here what it does. I didn't get a response answer here, okay. It just says total tokens, completion tokens, prompt tokens, all of that. Now there is, if you go through this, there is something called tool calls. And in the tool calls, it says multiply. And within that, it says arguments A is 5 by B is 3. Right? So we have not, in general, when you call a Python function, when you build application, you will do this. You have to call, multiply, and then pass the parameters to that function to get the response. Right? That's what you do. Now here, you're not doing that. You're just giving a sentence, right? A text. Now the agent, now the LLM, not the agent here yet. We are not built the agent yet. Now the LLM understands this and says, I can break this up. I can use a tool to multiply, because now I have a tool, because we have bound the tools to the LLM. So it can use the tool. It understood and broke it up, this sentence, as this as the first parameter, this as the second parameter. Since I have to multiply, it knows I have to call this tool multiply with these arguments. So now it has built that, calling the tool function with the arguments. It identified A and B, and it identified it has to call the multiply tool. So tool calls. If you see here, there is no tool calls for this. It didn't call any tool. So he got the response. For the tool call, he didn't get the response. Yes, we will look into that. It just shows you the tool calls, not the result yet. Now, if I say 8 added to 9, it understands it has the addition. Now it says the tool calls, it will add the tool add. This is the second tool. And then it can do the parameters as 8 and 9. Okay, so that's how it can understand when a problem has tasks. It can identify the task, break it down, and then identify what are the tools available and which tool I can use to solve that problem. So what are the tools available for me? Multiply and add. So if there are any such tasks given to me where I can use the tools, it will use the tool. You can also give hints. Use the tool to do this, or use the tools. Or if you already know the tool name, you can also suggest use this tool, or you can say use the available tools. If you don't want to use the tools, you can also mention that in the prompt. Do not use tools, just answer from your own knowledge. Then it will not invoke the tools. So those instructions are also there to override, but this is the standard behavior where it can intelligently, autonomously take decisions. So one part of the agent framework that we have, so we have a LLM, we have the tools. Okay. Now, let's say this is the tools that we have built, right? In Python, we just declared LangChain, and then we said we have a tool here, annotation. So it identifies these as the tools which we can add to the LLM to bind the tools to the LLM. Now I have something called DuckDuckGo search. So this is a third party vendor which provides a web search tool. Using this tool, you can do the web search. So you create from LangChain tools, import DuckDuckGo search run, and then create this object called web search tool. Okay, let's install DDGS. It's asking me to install DDGS to DuckDuckGo search library. Let's do this. We run this. Okay, now go back, restart session.
So just one question.
Yeah,
In the tools, you have given a one comment, also the function name as a multiply. So what basis the agent understand this tool is for multiplication? Is it based on the comment you gave or based on name you given for the function?
no, it's the comments. It reads the metadata
Oh,
and then
okay.
understands this tool does this function. Name
Okay,
can be
based on
anything.
comments.
Yeah,
Okay, got
based
it.
on the metadata. Okay, now we have built this tool. On this again. Okay. See here, now I have LLM with tools, and in the bind tools, I have only added multiply and add. Okay, so these are only two tools that are available. Now, if I ask it to run this, it does. It gives me addition. It calls the tool add. It knows I have a tool, I can use it to solve this problem. Now, if I run this, it says it has multiply and add, but I want to know weather in Dallas today. Okay, but these tools will not help. Here they're just like addition and multiplication. And we know LLM does not have the knowledge for the latest current information. So what it does, I'm unable to provide real-time weather updates. However, you can check reliable weather website, blah, blah, blah. You know what you can do it yourself. So it does not yet have capability to do anything for this task. Now, what I do is I give it a new tool called web search tool. So I created this DuckDuckGo search tool. Now I'm giving the agent, hey, now you have a new tool in your tool set. Let's see if you can use this. So now I do bind tools, multiply, add, and a web search tool. And then what I do, I will again ask the same question after giving this new tool. Now it says, see, now we don't get that response. Of course, we didn't get the actual answer, but you can still see here. See here, tool calls DuckDuckGo search. So it was able to understand and respond to the tool call. Okay. No, it cannot pick up based on annotation. See, annotations are like two, without annotation, it's a Python function, right? So when you put annotation as a tool, you are wrapping it up or making it a tool that can be used by the agent. Can be. But unless you add it to the tool agent's library, it does not know that you have created some tool. How does it know that you have created some tool? You have to give that information to the agent, right? Hey, here is the tool. You can use it. Otherwise, how would the agent know? So annotation is to make your function as a tool, convert it to a tool that can be used by the agent. But when can be used? When you add it to the agent's library, like bind tools. So no, anywhere wherever you go and create any agent, so there is no agent here yet. We are just binding it to the LLM model. This is another way of just adding tools to the LLM model. But whenever you create an agent, you have to specify the tools that it can use. There might be 10 tools that you have created, but you want to give access to only 2 or 3 tools to the particular agent, right? So there might be 4 or 5 agents. You don't give all 10 tools to all the agents. Again, you will restrict which agent needs to have access to which tool, right? So that is what you register with that particular agent. It's like registering your tools with the agent so that the agent can understand and know what tools is available for it to use, and it can use those tools. Okay. So here, yes, it has invoked the tool call. So, and to the tool, it has sent this query. See the difference. This is the query that we have sent, but it has chopped off and it has sent a crisp query to this tool. DuckDuckGo search. It just says keywords, Dallas, weather, today. No other all of this stuff. So it has, let's say if it didn't get a proper answer with this query, it will retry with a modified query again. So that's the intelligence that agents have, kind of. Okay, so this is the tool call. We want to test whether it is able to identify and call the tools that it has. So yes, it is. Now we didn't get the response yet. Okay, so we addressed the tools, which is the limitation for the current information that it can go and search. Then the 3 parts, right? We have the tools, we have the LLM. Now the third part is the memory. So these are all the tools that you can explore. LangChain community has. Okay. Are you still able to hear me?
Is it just me or?
Yeah, sorry.
Harun, you are
We couldn't
breaking
hear
in
your
now.
voice.
Last
Okay.
1 minute.
Yeah. I think there was some kind of internet issue. So we are like, we were able to create tools and add it to the LLM, and we can see the tool call is happening. Okay, so when the tool call is happening, it is able to understand what tool is there, what tool I can invoke to answer this question. So DuckDuckGo search, and it has the query formed this query, Dallas weather today. Though this is the query that we
Hello?
have given, it converted to this.
Okay.
We lost him again, I think.
Seems like.
Hello, I can hear you guys.